Now, good afternoon or good morning, Section 4 class. This is Mjuka. I'm here to discuss with you another very important topic in Section 4 for quantitative analysis, known as probability and probability distributions. Now, we'll catch straight to probability distributions. We all know what probability is. It's just chance. The probability that something might happen is something any manager or a business analyst might always be interested in. So the basic idea of probability is always the favorable outcomes out of total possible outcomes. So if something can happen maybe in 100 ways, but the favorable ones for you are 30, then the probability of you being successful will be 0.3. That is the main concept of probability. But I want us to narrow down to the most important bit, especially for you, that is probability distributions. Probability distributions basically comes from the fact that different environments have different variable behaviors. These behaviors of variables at different environments is what will form the probability distributions. Now, there are three main probability distributions which might be of concern for us. The first one, which is what I want us to look at in our first discussion, then next time we'll discuss another one, is binomial distributions. There is what is usually known as the binomial distribution. These are the distributions is just there will be some, for a distribution to take place, there will be some conditions which, if they are met, some formulas exist which can help you to solve various problems that somebody might want from you, like we will be seeing as we proceed. Now, in binomial distributions, this is a distribution which gives theoretical probabilities of discrete variables. In binomial distribution, this one was generated by somebody known as James Bernoulli, who presented his paper in 1713. And for binomial distribution to exist, there are some conditions which maybe the theory part I can let you to maybe go and look for, but make sure you can even explain to examiner the conditions or assumptions which must be met for binomial to exist. The most important one will be that the processes, the probability scenarios is like maybe if you want to toss a coin, that is a possibility. You might want to see whether will I get ahead or no. So if you're dealing with a scenario where outcomes for your experiments can either be only two outcomes, yes or no. Things like hit or miss. If that is what you might want to know, what is my chance of hitting or missing, getting yes or no, good or defective. If there are only two possible outcomes, then always think of binomial distribution. That is the first important condition. And the other condition is that we should be able to know from past experience the probability of success. Should be known. Probability of success is now maybe what are my usual chances. If you did an exam, you might always know from past experience that my probability of passing from past experience is usually this. So that one should always be known, and it will be denoted by a small p. And so is, of course, now the probability of failure. Okay, if the probability of failure is also known and it is q, it's just going to be 1 minus p. Like if your chances of succeeding is 0.4, of course, your chances of failure will be the remainder, which is 0.6. Once you have these two things, then discretely, the way we have said, discretely means we can now want to see if you attempted that exam 6 times. Somebody might want you to tell them what is the chance that out of the 6 trials, I will pass in 4 of them. If I did it 6 times, what is the chance that I will have this number of successes? So the probability of the required number of successes is what this thing is all about. And formula exists. We have formulas which can give you any required number of successes, provided binomial assumptions exist. There are others, you can go and read more. The formula for giving you any required number of successes, your calc can do it, will always be given by n combination r, p to the power of r, q to the power of n minus r. That is the formula you must put in mind. N combination r is in your calc, whereby now what we are saying is n should be the number of attempts, number of trials. If you did an exam 6 times, or if you try to hit something 10 times, you might want to see what is the chance I will get a certain number of successes. R are those required successes out of all the trials that you have done. And P is what we have discussed there. It is the probability of success. It will be given, or it must always be known. It's a condition that should be known. And Q will be the probability of failure. Okay? So provided a question is given and you have got all these things, then be assured that this formula can always generate for you whatever will be needed. And now N being now a number of trials. Suppose you have tried something 6 times. I'm saying PR could be told to get P0. Okay? That will be the chance that out of 6 trials there will be no success. You might be told to find P1. Out of 6 attempts there will only be 1 success. Those are questions which this formula can always sort you out with. Probability of 2 successes, 3 successes up to 6. So that if you did this up to 6, because you will be getting the chances now that these things must be exhaustive. All the probabilities by the time you're coming to 6 must be 1. And that is what, if we can also be able to show for today, then that will be a nice discussion. So look at that picture as we create a scenario where we might want to see the application of this formula. This is what make sure you can do for your examiner. Okay? So if we could move to another area so that just improvised my calendar for purposes of this class. I'm sure we are together. So what have we said? We have said the probability of any number of successes in a binomial distribution must always be, just remember, N combination R P combination P to the power of R Q to the power of N minus R. That is all you will need for a formula to work. So suppose now somebody told you that an event, imagine a scenario where you are told an event has the probability of success of 3 over 8. 3 over 8, if we could convert it into decimals, that is 0.375. So maybe you have got a chance of always succeeding in something 37.5% of the time, meaning your probability of failure will be the remaining 5 over 8. That must be 0.625. The question would give you such things. And that other things that you might now want to handle is how many trials did this person make? His chance of success is always 0.375, failure 0.625, and that he has maybe tried this thing 5 times. So what the question might want you, or one thing you might want to do is to get the whole binomial expansion or distribution. That means somebody might want you to show what is the chance of no success if the trial was 5. The question might ask you, what is the probability of 1 success? What's the probability of 2 successes? What's the probability of 3 successes? What's the probability of 4 successes, 5 successes, and 6 successes? And at 5, there are 5. So that you should be able to see by the time we are done, this thing must add up to 1. So I'll do a few of them for you, and then I will want to do the first 2, 3, and then I leave you doing the rest. And confirm that by the time you are done, the figure that you are going to put there will be 1. So if the question asked you for this scenario, the probability of that out of 5 trials there will be no success, then just put it there. All you will need to do is this. Now you write it as N is 5. So you have 5 attempts from our formula there, and combine it. Your calculator can do combination. We will see how it works. 5 combination R, remember R is now 0, so that will be 0. P is this constant here, which is 0.375 raised to the power of R. R is 0 times the remaining chance, which is Q, that will be 0.625 raised to the power of N minus R, that is 5 minus 0, that is 5. When you want to do the probability, if the question asks you what is the probability that there will only be 1 success, then just change R to this. You'll say 5 combination 1 times 0.375 raised to the power of R, which is 1, times 0.625, the remaining chance, 5 minus 1 will be 4, so that you can note that always the powers of what is here and here must be 5. It's an expression. So I've done this and this. You in your own time confirm for me the values on this other side, and then if you add them, it will be that. So what will be our answers now here? The probability of 0 that I've tried to put there, now that it is there, just take your calc, and if you have your calculator, you will just say, I want to do, remember, I want to do, put them so that you can see, I want to do 5 combination 0. 5 combination 0, you just say press 5, and your calculator has got a combination button somewhere, you press it, combination 0, times 0.375 raised to the power of 0, but we all know any number raised to the power of 0 is 1, so times 0.625 raised to the power of 5. So you just press them like that, the calc will do the rest. So it means the chance that there will be no success at all will be 0.0976. Probability of one success, which is this one, just substitute the figures there the way we have done. So this one will come to 5. We'll be saying 5 combination 1. We are solving this times 0.375 raised to the power of 1, which is also itself, that will be itself, times 0.625 raised to the power of 4. If you press the equal sign, so it means out of 5 attempts in a binomial distribution, the chance that you will only have one success is this one. I want you to complete this, get 2, get 3, get 4, just the way I've done, and 5 there, and add them. Confirm that, because you'll have captured everything that can happen. There were 5 attempts, and you wanted to know all the chances. It must add up to 1. That should be an assignment for that, and if you can do that, that is the most important bit in binomial distribution. Have a nice time. Do that practice.